Hitoshi is a researcher at SuperKEKB. He started out last April. He actually started there in April. Prior to that, he worked at JPark for about 9 years developing electronic circuits for physics and experiments. His talk will be Synchronized Timing and Control System Construction of SuperKEKB Positron Damping Ring.
Okay, thank you for introduction. I'm talking about synchronized timing and control system construction of SuperKEKB Positron Damping Ring. So my name is Sugimura from KEK. So this is the contents in my talk. At first, I'd like to talk about SuperKEKB project, and we're using the event timing system. I focus on the event timing system at damping ring, and the important timing is the pre-trigger. So I will focus on the pre-trigger timing, then conclusion. So this figure shows the SuperKEKB. And SuperKEKB is an upgrade of a KEKB project. This accelerator is an E plus E minus collider, and the total energy is adjusted to the epsilon 4s state and decay to the B meson. So we are calling it the B factory. So beam luminosity is aiming at 40 times higher than previous KEK project. So to achieve this, we are increase the beam current, so twice larger storage beam, and we need to focus on the collision point. So we are aiming the 20 times higher collision rate with nanobeam scheme. So SuperKEKB accelerator is a four ring. So one is a HER for electron beam, and LER for positron beam. And then two ring is a light source. And the damping ring is newly constructed at the middle of the injector line-up. So I will talk about damping ring specification. So the beam parameter is listed in the table. So at damping ring, emittance becomes down to 1/500 during damping time. So damping time, assuming the 40 milliseconds, while LINAC operates at 50 Hz. And beam bunch can accommodate 2 bunches times 2 pulses. And 2 bunches in a pulse are separated by 96.3 nanoseconds, which corresponds to about 10 megahertz. And the KEK magnet, rising time and falling times are 100 nanoseconds. So we should separate 2 pulses more than 100 nanoseconds. So from now, I will talk the event timing system, simultaneous top-up injection. So we are using the timing system of MRF series event generator and receiver, BMW EVG 230, EVR 230, and PXI EVR 300. So synchronized with the 114 MHz RF clock, and the data transfer the 16 bits per clock. And we are using a system communicate with the VME64X CRED and PCI Express. And the software is VXWorks version 6.8 and Windows. And the EPICS is using version of the 3.14, 12 with MRF IOC2. So I will explain the injection and extraction timing at damping ring. So RF frequency is different between the LINAC and the ring. So LINAC RF uses S-band, and damping ring and MR is using about 500 MHz. And the timing, injection and extraction timing is 2 timing is needed. And the common frequency between S-band and 500 MHz is about 10 MHz. So the chance of the injection timing turn up once per 96 seconds, which corresponds to the 49 buckets. So we need to consider the bucket selection combination, HDR and MR buckets. So the total number of the combination is about 1 million. This value calculated by the least common multiple of DR and MR. So to satisfy this, we have constructed the master timing system at injector LINAC. This is consists of the one upper EVG and one upper EVR and 2 lower EVGs. So this system operates in one IOC. And this signal is delivered dozens kinds of timing, BPM, kicker, septum, and so on. So upper EVG calculates which bucket is injected and extracted. We are calling the bucket selection. And the lower each EVG is set to delay timing according to bucket ID. So let's focus on the damping ring. So at first, I will explain the timing constraints at damping ring. So the most important timing is the kicker injection and extraction timing. And this is the most important to have effect of beam jitter. And the injection or extraction kicker needs charging trigger for 15 milliseconds before firing. So this value we call pre-trigger. Next is the pulse train should be provided for BPM at the revolution frequency and synchronized to one of the beam bunch in DR. And in operation phase, so we wanted to measure the dispersion. So the RS frequency is changed less than 50 kilohertz. So to operate this system, so we should be disconnected from other clock. So we are setting up the event timing system at damping ring. Left figure shows the main timing system, and 2 timing are going to the 2 EVRs. Upper is the injection timing, and lower the extraction timing. So at damping ring system, the timing is generated. The pre-trigger and main trigger are going to some equipments. And dispersion for dispersion measurement, we set the delay logic and inserting the damping ring RF. So EVR for injection and extraction timing distributes 2 timing, main timing and pre-trigger timing. The pre-trigger timing is originally generated EVR itself, and for dispersion measurement, the variable delay logic is added. So I will explain the pre-trigger timing. So this is the event stream from EVG to EVR. So event is sent from EVG to EVR every 20 milliseconds. So the horizontal axis is time. So we're supposed to think about the DR injection timing at the shot number n. So black arrow shows the MR timing. So MR timing send every 20 milliseconds, and which added to the bucket selection delay. So we call the bucket selection delay D main, and D main will change shot by shot due to bucket selection. So I described the bucket selection delay at D main n-2, n-1, n. And also, so other event is generated from the EVG. So pre-event, we call the pre-event sent to the from EVG to EVR. So this indicates the next event is a damping ring event. So we are set to the pre-trigger gate between the pre-trigger, pre-event. Then we want to know the delay time from EVR to some equipments. So delay time for pre-trigger is sent from EVG via the data buffer before shot number n-1, then set the pre value. So pre-trigger timing is generated from MR timing. So this black arrow shows up MR timing. So the count from EVR to D pre, then generated the damping ring pre-trigger at blue arrows. So main trigger timing is generated from line timing with no delay. So we are using the main timing at the same timing at the line timing. So red arrow shows the main timing. So the delay time D play from MR timing is calculated as equation number 1. So the D main minus D main n minus 1 plus 5 milliseconds. So this value is sent from EVG to EVR. So in this system, so timing jitter, it is measured with 30 picosecond jitter. Of course, so MRF system originally 10 picosecond jitter, but so this value is including the RF jitter and cable jitter totally. Okay, then conclusion. So SuperKEK project, I'm at 40 times higher luminosity than previous KEKB project. So operation of damping ring will be started in this fiscal year. So injector line-up, damping ring, EPIX control system, event-based synchronized system are being constructed. And pre-trigger system was constructed with 30 picosecond time jitter. So we are starting from now. So long stability test will be started soon. Okay, that's all.